All right, so again, in lesson 8 here in module 4, we are focusing on percent error problems, right? This whole module has been on percents, and now we're trying to figure out, hey, if we're measuring things, what percent are we off? Okay, so keep in mind that we have this formula where we take the absolute value of the approximate measurement, subtract the exact measurement, and then divide that by the exact, right? The absolute value of the exact, but it ends up just being the exact. And then we multiply it by 100. That part right here is just turning it into a percent. So remember, I just moved the decimal point 2 places to the right. Okay, so let's get examples. A real estate agent expects 18 people to show up, but 25 people attend. So the decision you have to make here is what's your approximate, what's your exact? Well, exactly how many people attended? 25. We were approximating what? Or the real estate was approximating what? Real estate agent. 18. So if you can identify that, then it is just plugging into your formula. So we're going to take the absolute value of what we expected, what we approximated, 18, minus our exact, 25. And then we're going to divide it by 25, right? That was the exact. So 18 minus 25 is a negative 7. But because it's absolute value and we don't care that it's negative, this just ends up being 7 over 25, which is 0.28. Now, here is where this times 100% comes into play. If you times this by 100, you get 28, right? 28%. I tend to think of it as we're just moving our decimal place over 2 times to the right. And so this ends up being a 28% error, right? How? The real estate agent was off about 28%. Okay, 7 people, which is 28%. All right. So let's look at another example. Again, I think the trickiest part to this will be exact and approximate, making sure we get that correct. So we're going to use this formula still. In science class, Mrs. Moore's students were directed to weigh a 300-gram mass on their balance scale. Tina weighed the object and reported 328 grams. So I tend to want to say, hey, she weighed it and it was 328. That means exactly what it is. That's human error, right? It is a 300-gram mass. This is what it is exactly. Tina messed up when she weighed it, and this 328 here, that's her approximate. Okay, and I know they can be a little quick, and I get this one, like I want to say she did it correctly. Nope, if it's 300 grams, that's what it's supposed to be. So, using our formula here, right? The absolute value of our approximate, 328, minus our exact, 300, divided by the exact, 300. So that ends up being 28, and the absolute value of 28 is 28 over 300. And we get 0.09 and then a bunch of 3s. Be careful not to combine steps. Like I know I combined them here, but don't combine them here. Don't try to turn this into percent until after you've written it down, because what happens is we tend to lose things. We lose our decimal point, okay? So if I write this out and I times it by 100, or I move the decimal point 2 places to the right, I end up with 9.3 repeating percent, or like we talked about before, that's like 9 1/3, right? And I don't care if you write as 9 1/3, you write as 9.3 repeating, or you say it's approximately equal to 9.3%. Just make sure you put the percent sign, okay? So poor Tina here, she had a 9.3 repeating or a 9 1/3% error. Okay, so she was off about 9.3%. All right, let's do this last example here, right? Okay, so pay attention to this one. This one's a little bit different because in this one, we're estimating the percent error. So the last 2 examples we did, we were like, hey, use the formula. Here's the exact. Here's the approximate. See how this one's a little different. Sorry, we have 2 more we're going to do. The attendance at a musical event was counted several times. All counts were between 573 and 589. If the actual number is between those, inclusive, meaning it's inside those two numbers, okay, not gonna be outside of them, we know it's somewhere in between those numbers. What is the most the percent error could be? What is the most the percent error could be? Okay, so here's what you have to do. You know it's in between those, so that's what we're going to subtract. In our formula right here, we're just going to subtract them, okay? And because it's the absolute value, it doesn't matter if you can go bigger minus smaller or smaller minus bigger, okay? So I'm going to go 589 minus 573. Could do it the other way, like I said. Now, here's a trick. What do we divide by? Because we want the most it could be, we want to divide by the smaller number. If you divide by a smaller number, your percentage is bigger. So I'm going to divide by 573, okay? And again, you're paying attention to this problem because you're going to see something like it on your homework. That's why we started here, right? This is going to be the smaller amount. If you want to know at most what your percent error is going to be, you divide by the smaller amount, okay? So this works out to be 16 over 573. And we get this 0.027923. All right, so we're just going to say it's approximately equal to 0.02, did I say 29? 279. Dot, 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 right? It's going to keep on going, okay? So now I'm going to change it to a decimal, and we'll move it over 2 places. And I'm going to say, you know what? It's going to be approximately equal to 2 point. And I know I haven't been using approximately, but it's because I had repeating. So I was putting repeating bars over it. This one, it's all random, so, well, at least it looked random. And I'm going to say it's approximately equal to a 2.79 error. That's the most it could be, okay? By taking either of those numbers, the most we're going to be off is 2.79%. Okay, so that one's a little bit different. So when you get one like this where we're estimating the percent error, then you have to just subtract them. It's going to fall somewhere in between there and divide by the smaller amount. Okay, one more example that I want to show you that is going to be like your homework. All right, this problem's a little bit different, but again, it's going around how we understand percents, okay? So Shaniqua has 40% less than her older brother Jax, okay? So let's think about this right here, okay? Shaniqua has 40% less money than her older brother Jax. So what percent of the money does she have? Well, if we go 100 minus 40, that's 60, right? So she has 60% of what Jax has. Okay? 1s. Okay. So of, remember, means to multiply. So if I move my decimal point over, because again, don't multiply or divide with percents, change it into decimals, I can go 0.60 times whatever Jax has, right? And that's going to be what Shaniqua has. She has 180. Okay, so 60% of Jax equals 180. So if we divide, because I'm solving for J, I have to get rid of the 0.60. It's multiplying. I undo that with dividing. Okay, 0.60 divided by 0.60 is 1. And then I can take my calculator and go 180 divided by 0.6, and I get 300. Okay, so what does Jax have? Jax has $300. Okay, so because Shaniqua has 60% of what he has, and if she has 180, then it makes sense that he's going to have more money if he's 300. Okay, that one's a little bit different, but it comes in here, instead of thinking of it as less, you want to, it's not really a percent error, but you're thinking of it as a percent of something. And I just want to touch on that because you might see something like that in your homework as well. Okay, don't stress about this problem. Make sure you have it written down to help you out. But our big thing, again, is percent error and using this formula to figure out what percent off a measurement can be.